So, well, now we're going to answer a question that was asked, I think last week sometime, maybe before even. Why are some acids strong and some are weak? Why do some hydrogen-containing compounds act as acids and others do not? So, if we look at H2S versus CH4, well, CH4, we've written the H's at the end, which suggests they're not acidic, but why isn't it written HCH3? Why isn't one of those acidic? Why is HCl a strong acid, and why is HF a weak acid? So first we'll look at the binary acids. So these are acids without oxygen. So we're going to look at the bond between the hydrogen and whatever element it's attached to. So it could be chlorine or fluorine. In order to act as an acid, that hydrogen must be donated. And so both the strength of this bond and its polarity are going to affect the acidity of that compound. To be acidic, we have to lose the hydrogen ion. We can't just break that covalent bond and lose a hydrogen atom. That would not be acidic. So the bond must be polarized, with the hydrogen end being partially positive and the other end being partially negative. Remember, this has to do with electronegativity. Electronegativity is the attraction that an element has for the electrons in a covalent bond. Fluorine has the highest electronegativity, and we can look at the trends that, comparing any two elements, whichever one's closer to fluorine, we would predict is higher in electronegativity. So here we have three different situations. The HC bond is a nonpolar bond because hydrogen and carbon have very similar electronegativities. And so what I tell my 1A students is, if you have two different elements, you should, guess that the bond is polar, except with hydrogen and carbon. That's a very common one, and it's important, and it's worth remembering. Hydrogen-carbon bonds are nonpolar. They share equally. Here we have hydrogen and lithium. Well, here, the hydrogen is actually more electronegative than the lithium is. And so the hydrogen end of this bond is going to be negative, and the lithium end is going to be positive. So if this ionized, we'd end up with Li plus and H minus, and that does not meet the definition of an acid. This is not going to form ions if you break that bond. Here, we're going to form ions. The fluorine would be negative, and the hydrogen would be positive. So we have to have a polar bond with the hydrogen on the more positive end of that polar bond. So what about the strength? Well, the stronger that bond is, the weaker the acid is. Because if that bond is really strong, that hydrogen is much less likely to be lost, right? A strong acid just loses all of its hydrogens. It's like, whatever. So those bonds are weaker. So HF, and this is one of the things that always kind of bothers me, is like, okay, so that's a really strong bond, right? And fluorine is the most electronegative. And then HF is not a strong acid. That seems kind of backwards. But it is not a strong acid because fluorine holds on to hydrogen so tightly. If we look at bond strength, as we're going down in a group of the periodic table, what's happening to the size of those atoms? They're getting bigger, right? So fluorine is small, chlorine is bigger, bromine is bigger yet, and iodine is the biggest. The bigger the atoms are, the weaker the bonds between them will be, because there's more distance between them. So HF is a very strong bond. So here we have strong bond energy, and so that hydrogen is less likely to come off. So the bonds get weaker as we go down, and so the acids become stronger. All of these guys over here are weak acids, but I guess you'd call that hydrotelluric acid is a stronger acid than water is. Any questions? In my opinion, the only way that you can remember stuff like that is by being able to reason it out. I mean, I teach this class every year, and it's not just available on the top of my head. I have to think it through. So that's probably what you're going to have to do as well. What about the oxyacids? So oxyacids, we've got a hydrogen atom. Bonded to an oxygen atom, and the oxygen atom is bonded to something else. So it's not something that we learned about in, well, we kind of did, but it was not emphasized. So if you have, say, hypochlorous acid, it's HClO. The hydrogen is bonded to an oxygen. If we have something like sulfuric acid, H2SO4, the sulfur's in the middle. This is not a Lewis structure. It's just showing how the bonds, what's connected. The hydrogens are connected to the oxygens. They are not connected to the non-oxygen element. The oxygens are connected to that element, or calling it Y, and any hydrogens are connected to oxygens. So we're looking at this situation here. We've got a hydrogen attached to the oxygen, and this is a polar bond, right? So we've got the possibility for this to be acidic, right? So the identity of this element Y is going to affect the strength of that bond. So if Y is more electronegative, then Y is pulling the oxygens from this, the oxygens. No oxygens are being pulled anywhere. Y is pulling electrons from the oxygen. And the oxygen's pulling electrons from the hydrogen, and so that makes that bond weaker. So here we're looking at HIO, BRO, and CLO. So chlorine is the most electronegative of this group. It's closest to fluorine. So this is pulling electrons away from the oxygen, which in turn is pulling electrons away from the hydrogen. If you like the stealing the blankets when sleeping in the same bed analogy, now we've got 3 people in the bed, right? And oxygen's stuck in the middle. And this guy over here is pulling the blankets away from oxygen, and oxygen is pissed. And so oxygen is stealing blankets more than before from the hydrogen. And hydrogen is left out in the cold, literally, and you could think of him as falling off the bed without the blankets. There you've got your H+. Right? So the more electronegative this is, the weaker this bond is. So chlorine has the higher electronegativity. Its Ka is larger, meaning it ionizes more than those with lower electronegativities. Does that make any sense? We've got some nods and some, not so sure.
If I was I'd start calling back the Y though.
Yeah, but
You know where the blankets are going. You know where they are.
yeah, but there's just limits by the electronegativity here, and so oxygen cannot pull back like it would like to because it's less electronegative. So the identity of Y matters, and also the number of oxygens matter. So the more oxygen atoms that are bonded to Y, the stronger the acid is. because now we've got oxygen atoms are pulling blankets or electrons away from that element Y, who's pulling back, but pulling more so from the oxygen with the hydrogen, and so the hydrogen has even less, the bond is weaker. So here we're comparing the 4 oxyacids that chlorine forms. Perchloric acid is a strong acid. We should know that because it's on the list of 6. There's only 6 of them. You have to memorize the 6 strong acids. Perchloric acid is one of them. HClO3 has a Ka of 1, which means that as far as weak acids go, it's pretty strong, because a Ka of 1 means that half of those ions, half of the acid molecules are going to lose their hydrogen. And then with 1 less oxygen, we see that the Ka becomes smaller, and with 1 oxygen, it is much, much smaller. Because here we only have the 1 oxygen, we don't have any assistance coming from these other oxygens on pulling blankets away from hydrogen. And so this bond is going to be stronger. Stronger bond, weaker acid. This one is going to be a strong acid. Any questions? So we can have questions like this. Which of the protons shown in red is more acidic? More acidic means more likely to be lost, which means the bond that hydrogen has is weaker. So between these two, we're looking to see this oxygen-hydrogen bond, which is going to be weaker. So this carbon has hydrogen and oxygen. The hydrogen carbon, they share things equally, they're fine, but oxygen is an electronegative element, and so it's going to pull electron density away from other things. Over here, this carbon just has 3 hydrogen atoms, and so there's no assistance in pulling away electron density. So which one of these has the weaker bond? A. The weaker bond is going to be the more acidic. Because when it acts as an acid, the hydrogen comes off. The hydrogen will come off more easily if the bond is weak. Well, I'm just going to go off here. So let's look at this. Analogy I use in Chem 1A about losing children at the Fresno Fair. Right? So I have 6 children. When I only had 2 children, I would occasionally go to the fair, but I could hold one with each hand, right, and keep them around me. Fairs are just a great place to waste money, in my opinion. So I wasn't too keen on going anyway. But then when you've got like 6 kids, right, and you go to the Fresno Fair, not only is it really expensive, but how are you going to keep track of 6 little people, right? So big family, it's a lot easier to lose a child, right? Because you just can't literally hold on to them. So fluorine is a small family, 1 child. So mom takes the 1 kid, and her focus is on that kid. That kid is not getting lost, right? But as the family gets bigger and bigger, it's easier to lose children. Not a real PC analogy there. I will tell you, I have never lost a child for more than a few minutes. We always got them back within half an hour. So So they're all safe. So these guys are strong acids. Okay. Then of the oxyacids, right? We've got the ClO4, and so we just learned about that one. So the chlorine is quite electronegative, and it's got 4 oxygens pulling away, and so that makes that bond with the hydrogen very weak. If you had HFO4, which doesn't actually exist, that would not be a strong acid either, because that bond is too strong. What are the other ones?
Phosphoric acid.
That's a good guess. That's a good guess, but no.
Sulfuric?
Sulfuric acid. And nitric acid. So nitrogen is fairly electronegative. Sulfur is fairly electronegative. Chlorine, and so these 3 here are the oxyacids that are going to be strong. Notice that it's HSO4, it's not, H2SO4, it's not H2SO3. H2SO3 is one less oxygen, less pulling of the electrons away, the bond is stronger, it's a weak acid. Here's nitric acid, that's strong. Nitrous acid, NO2, not strong. So if that helps you remember, great. If not, sorry, I tried. Any questions?